Can you guys expand a plus b to the power 0? 1. How about a plus b to the power 1? A plus b. And just for fun, I'm going to put a 1 there. Okay, so I'm going to put to the exponent 1. I'm also going to put a 1 in front. Not that you would do that normally. Okay, what about the next one? A plus b to the power 2. A squared plus 2ab plus b squared. And again, I'm going to put a 1 there and a 1 there. So do you remember the video from yesterday? The triangle. Let's scroll down to and make this triangle. Do you remember how to make the triangle? You put 1s all the way down the first side and the other side. Then what? Then you add. Very good. So then 1 and 2 make 3, 2 and 1 make 3, 1 and 3 make 4, 3 and 3 make 6, 3 and 1 make 4, 1 and 4 make 5. We have 10, 10, 5, 1. Yes? 6, 15, 20, 15, 6, 1. And we could go on and on and on. Do you notice anything about the numbers of what we were doing up there? Yeah, do you notice? What do you think the next one would be then? 1, 3, 3, 1. What would the next row coefficients be? 1, 4, 6, 4, 1. And what would the next one be? 10, 10, 5, 1. Okay, so let's see if we can get the other pattern of this binomial expansion. What's going on here with the a's, for instance? Can anybody guess what the next row will be? A to the power 3. What would the next term be? 3a squared b. Very good. What would the next term be? I'm sorry? Say it again. I hear a squared. It's not a squared. AB squared. Thank you. And what would the last term be? B cubed. And these are all pluses. Okay, what's the pattern going on here? Can anybody see the pattern here? 3, 2, 1. And guess what? There's an a to the power 0 there. Yes? What's happening with the b's? It's going 3, 2, 1, 0 the other way. So, knowing that, what can we get for the next row? 1, a to the power 4 plus 4 a3b plus 6a squared b squared plus 4a b cubed plus, what's the last one? B to the power 4. Okay, let's do the last row now. What's that going to be? A to the power 5 plus. So then this would be A4B. And this would be A cubed B squared. And this one would be A squared B cubed. This one would be a b to the power 4, and this one would be b to the power 5. Okay, so let's notice from the expansions, the number of terms is blank more than the blank of the binomial. I'll say power. What is it? It is 1 more. So what I'm saying here, do you see the power of the binomial is 0? I have 1 term. The power of the binomial is 1. I have 2 terms. The power of binomial is 2. I have 3 terms. Yada, yada, yada. So if I said if the power of the binomial was 99, how many terms would I have? 100. That's a great multiple choice question. The blank of the exponents is always equal to the blank of the binomial. The sum of the exponents is always equal to the power of the binomial. So what I mean by that is it looks more obvious when I get to the lower, when there's more stuff going on here. Look at this. Power is 4, 4. 3 and 1 make 4. 2 and 2 make 4. 1 and 3 make 4. 4. Do you see that? So the sum of the exponents is the same as the power of the binomial. Yeah? Okay, next one. The exponent of the first term a begins with the same value as the power of the binomial. Do you see? I started with a squared, and that's what it was to the power. I started with a cubed. That's what the power was. I started with a to the power 4. And then it decreases by 1 each successive term. And then what happens with the b? The exponent of the second term b is 0 in the first term, right? The exponent to the power is 0 in the first term. And then it increases by 1 for each successive term until it matches the power of the binomial. Okay, so knowing all this, let's expand x plus y to the power 6. So I know it says step 2, start with the coefficients. I like actually starting with the coefficients. So if it's to the power 6, I need the one that has 7 terms in it, right? That's row 7. 1, 6, 15, 20, 15, 6, 1. So I'm going to do that. 1, 6, 15, 20, 15, 6, 1. Does everybody see where I got that from? Now I'm going to do the exponents. I'm going to start with the first one at the same power as the binomial and then go down each successive term. So x to the power 6, x to the power 5, x to the power 4, x to the power 3, x to the power 2, x to the power 1, and then x to the power 0. Everybody see what I'm doing here? And then I'm starting with my second one with the to the power 0, which I won't write. Then y to the power 1, y to the power 2, y to the power 3, y to the power 4, y to the power 5, y to the power 6, and then I'm going to put plus between all of them, and then I am done. What do you think about that? Otherwise, you'd have to multiply this out, right? Well, first you'd have to FOIL it, then you'd have to do a multiple distributive properties to get this, right? Okay, so something you're supposed to notice besides the Pascal's triangle is that the coefficients are actually the combinations. So 6c0 we know is 1. 6c6 we know is 1. Does anybody know what 6c1 is? That was something you were supposed to memorize too, right? It's 6, right? 6c2 you probably wouldn't have memorized. So 6 factorial, so I'll just write it here. 6c2 is equal to 6 factorial over 4 factorial, 2 factorial. This would reduce down to 6 times 5 divided by 2. So do you see I get 15 for that? Yes? And do you see that 6c4 would give you the same value? So that would be 15 as well. Do you see how I can do these combinations so fast? And then 6c3 is 6 factorial over 3 factorial, 3 factorial. So I'm going to reduce this. So I get 6 times 4 times 3. And then 3 factorial is 3 times 2. So the 3 and the 2 and the 6 cancel, and I get 20 out of that. So do you see? I can also, instead of reproducing Pascal's triangle, I can get the coefficients by doing the combinations as well. Either way works. Most people prefer Pascal's triangle. What they do is as soon as they get the test or the exam, they just reproduce it, right? It's pretty fast to reproduce. I don't think I have it anywhere in here, do I? No. So something that you should know about the coefficients of the expansion is the coefficients a plus b to the power n are in the n plus row of Pascal's triangle. So I had this conversation with somebody that takes computer science. Apparently in computer science, they start with row 0 and then go. So in math, we start with row 1. So this is row 1. The power is 1 less than the row number, right? Or you could say the row number is 1 more than the power. They've asked this before in the exam, and so there was a controversy because some people referred this to row 0 and others as row n plus 1. Okay, I'll help you with the first one. So this is x minus y, and then I'll just give you some time to expand these. So does everybody see how the pattern goes, right? Okay, so something to the power of 5 would be which row in your, it would be the 6th row. It's the one that has 6 terms in it. 1, 5, 10, 10, 5, 1. Does everybody see that? So 1, 5, 10, 10, 5, 1. Okay? Then we do the first term, which is x. So x to the power 5, x to the power 4, x to the power 3, x to the power 2, x to the power 1, x to the power 0. Now here's the thing. The pattern for a binomial expansion is in the form a plus b to the power n. This is not a plus. So how can I rewrite that? Well, this would be x plus negative y to the power 5. So do you see my b is actually a negative y each time, not just y. So it would be negative y to the power 0, negative y to the power 1. Make sure you use brackets because you have a negative that's going to the complete power here. Negative y to the power 2, negative y to the power 3, negative y to the power 4, negative y to the power 5. So again, it goes all pluses here, but you'll see what happens after I expand it. The first one will just be x to the power 5. Everybody agree? You don't need the 1 in front. So now what happens when I simplify negative y to the power 1? I get a negative, right? A negative to an odd power is negative. So this will no longer be plus. It'll be minus 5x to the power 4y. So this negative here to the second power, when I square it, it'll become positive. So the next term will be plus 10x cubed y squared. Does everybody see what I'm doing here? This negative to the third power will now make an extra negative for the plus, so it's going to be minus 10x squared y cubed. This negative to the fourth power will make it positive, so then it remains as plus 5xy to the power 4. And then this negative to the fifth power will make it negative y to the power 5. So there's my final answer. Okay, so the next one, what you have to realize is A is this complete term, right? Do you want me to help you with this one before I go into C? Okay. Huh? Okay, so this is to the power 3, so that we're going to look at the fourth row. So if I go back, the fourth row would have 1, 3, 3, 1. When you do this enough times, you'll remember all the numbers, really. So again, 1, 3, 3, 1. Everybody know how I got that? Okay, so now I'm going to have a to the power of the binomial, but a is, in brackets, 2x to the power 3. In brackets, 2x to the power 2. In brackets, 2x to the power 1, and then in brackets, 2x to the power 0 will just be 1. Then I'm going to start with y to the power 0, y to the power 1, y to the power 2, y to the power 3, and all of this is plus until it changes because of a coefficient. So now, you remember bed mass. You got to do exponents, right? So that means we need to simplify 2x to the power 3. So what do I get? Yeah, 8x cubed, because it's not going to change with the 1. Okay, how about this? What do I get there? 4x squared, but then I still have to multiply it by the 3. So I get 12x squared y. Does everybody see what I'm doing? Okay, so then the 2x is to the power 1, and then that's just 2x, and then I multiply by 3, I get 6xy squared, and then this doesn't change. So then that's my final answer. All right? You guys want to try C? You don't. Why? Okay, so how many terms does a power 4 have? 5. So I'm looking at, whoops, I'm going the wrong way. I'm looking at the one that has 5 terms, or row 5, 1, 4, 6, 4, 1. Yes? 1, 4, 6, 4, 1. Yes? Okay, the first term is x squared, but x squared is going to be in brackets now to the power 4. Then it's going to be x squared to the power 3. Then it's going to be x squared to the power 2. Then it's going to be x squared to the power 1. X squared to the power 0. Then I'm going to have 2 over x to the power 0, 2 over x to the power 1, 2 over x to the power 2, 2 over x to the power 3. Again, if you don't have brackets, you will lose error codes. 2 over x to the power 4. There is a bunch of pluses between all of these. Okay, I'm going to actually move this up because I'm going to run out of room here. Oops. Okay, so now we're going to simplify this. Why is this not letting me do that? There we go. Okay. So we might have to do this in a few steps because there's lots going on here. The first one's not so bad. What rule do you use when you have a power to the power? You multiply. So this is going to be x to the power 8. Yes? So I'm going to do this in another step. So I'm going to do this slowly. So plus 4, what do I get here? X to the power 6, what do I get here? 2 over x. So then, in my next step, what does that simplify to be? You have to multiply the 4 times the 2, and I get a 8. And then what does x to the power 6 over x simplify to be? X to the power 5. Okay, next one. I'm going to get 6. What do I get out of this concoction there? X to the power 4. What do I get out of this concoction here? 4 over x squared. So now I'm going to multiply the 6 times the 4, and I get 24. And what does this simplify to be? X to the power 4 over x squared. X squared. Moving on. Over here, I get 4x squared. What do I get out of this concoction here? 8 over x cubed. Okay, so let's simplify. 4 times 8 is 32. What does the x squared over x cubed simplify to be? 1 over x. So we're just going to put this over x, and the x is going to be at the bottom. We don't have negative exponents, right? And then this will become 16 over x to the power 4, which is just 16 over x to the power 4. So there's my final answer. Notice that even after I simplified all of these, that there is a pattern going on with the x's for powers, right? It's going x to the power 8, x to the power 5. Do you see it's going down by 3 each time? That should happen after you simplify and you do everything right. There should be a pattern to how much it's going up or down by. Okay, so the binomial theorem is a formula on your formula sheet, and what it says is if you have a plus b to the power n, to find any specific term number, because like what happens if I were to expand this to the power 100 and I only wanted to find term 80? You're not going to expand it to find term 80. That would take way too long. So notice that if I wanted to find a specific term number so for instance, this is term 2. Do you see? That the combinations give you the coefficient, because you're not going to maybe go up to the 100th row of the Pascal's triangle. So we're using combinations here to figure that out. And notice that the first term, I don't know if that's the best one. Maybe I should look here. So if I look right here, do you see that the second term is, this is to the power 3? And so what they're saying is if you take the power and subtract what term number you're finding, the term number is k plus 1. So if I'm finding term 2, then k is 1. Term 2. Term 2, that means k plus 1 would be 2, yeah? So k is 1. So do you see? N minus 1 would give you the 3 for that power. And then the k value would give you that power there. Okay, so we'll do a couple examples. So if I want to find the fifth term, I'm finding T5. Remembering that that is k plus 1. So what does k equal then?
4.
4. What does my n equal? What does my n equal? My n is right there. N equals 7. Yes? Okay. Everybody see 2x is my a term. 5 is my b term. Yes? So we're just going to plug it in the formula. So NCK, so that would be 7C4. Everybody know where I'm getting this from? Then it's going to be the first term. I'm running out of room here, so I'm going to erase this. Sorry, I'll do it the other way. This is my A, and this is my B. Okay, so that's the first term, so that's going to be 2x. And that's going to be to the power n minus k. Remember, n was 7, k was 4, so 7 minus 4 is 3. And then the second term, which is 5, that's going to be to the power k. So that would be to the power 4. Remember that at any point in time, these two exponents should add up to what my n is, right? Or my n is here. So 7C4 is probably nothing we need a calculator for, do we? Huh? So 7C4 is 7 factorial over 3 factorial, 4 factorial. So this would simplify, yes, to 7 times 6 times 5, yes? And then the 3 factorial is 3 times 2. So 3 and 2 and 6 will cancel, so I'm left with 35. So this would be 35. What's 2x to the power 3 going to give you? 8x cubed. What's 5 to the power 4 going to give you? 625. Very good. Well, maybe this would be a calculator question, I guess. 35 times, does everybody see now what I'm going to do is I'm going to take 35 times 8 times 625. Yes? So what are we going to get then? 35 times 8 times 625. Ooh. 175,000 x to the power 3. So the fifth term in the expansion of 2x plus 5 to the power 7 is 175,000 x to the power 3. No, the calculator will be part calculator, part non-calculator probably. Okay, let's try to find the fourth term. So T4, what is K going to equal then? 3. What does N equal this time? 4. How many terms does this expansion have? 5. Okay, so the fourth term is equal to NCK. So it's going to be 4C3. Everybody good with where I'm getting this from? The first term is 2x, and that's to the power n minus k. So that would be 4 minus 3, which is 1. The second term, which is minus y, again, if you don't have brackets, it looks like subtraction. That's not correct. Negative y to the power k, so 3. At any point in time, these two exponents should add up to your n value, right? What's 4c3? 4. What's 2 to the power 1 to the, 2x to the power 1, would just be 2x. And then what's a negative y to the power 3? Yeah, negative y cubed. So what's my final answer? Negative 8xy cubed. Everybody understand how I got that? Find the middle term. For some reason, people always have trouble with this. How many terms does this binomial have? 5. What's the middle term? Whoa. I do that every year. And I always point it at somebody. Yes. I have 5 terms. What's my middle term? Flip the bird. Okay, term 3. Term 3. K is 2. Thank you. What's N? Still 4. Nothing changed, right? So NCK. 4C2. First term, which is 2x to the power n minus k, so 4 minus 2, 2. The second term, which is minus y, is going to be to the power k, which is 2. What's 4c2 equal to? No. I think it's 6 here, people. 4 factorial over 2 factorial, 2 factorial, right? 4 times 3 divided by 2, I get 6. 2x to the power 4 would be 4x squared. Negative y squared would give you y squared, positive, right? So then what do I get as my final answer? 24x squared y squared. Okay, moving on. In the expansion, so let's find the fifth term. What does that mean? T5. That means K is 4. N is 10. I always like writing those things down underneath it. Okay. So NCK. So that is 10C4. The first term, which is x cubed, and that's going to be to the power 6. The second term is negative 2 over x squared, and that's going to be to the power 4. Everybody good with that? Yeah? Okay, so let's use our calculator for this one. So 10c 4 is 210. Yes? X to the power 3 to the power 6 is x to the power 18. What's negative 2 to the power 4? Yeah, so this is going to get 16 over, and then I have an x squared to the power 4. X to the power 8. Everybody good with that? So 210 times 16 is 3,360 x to the power 10. Very good. Okay. Now it's asking you for the term containing x to the power 15. So notice this x to the power 10 has nothing to do, well, you might fluke and get, oh, that means those add up. No, that's just a fluke. That has nothing to do with these things. So the problem here is I don't know what in order to solve this. Huh? I don't know the k value. If I knew the k value, I'd know the term number, and if I knew the term number, I could use the formula, right? Okay, so how could I figure out what the k value is? Okay, so there's two methods here. Method 1, expand to find a pattern to get k. I do not recommend this one, but sometimes this is the only way people understand, so I'm going to show both, okay? So, expand to find the pattern. The problem about expanding is some people don't get that, like, all I'm trying to find is the pattern of x's, and maybe I need to specify that. The coefficients don't matter in the pattern. Do you know what I'm saying? Like if we look back over here, let's look at this example here. Do you see what's the pattern of the x's? It's the powers are going down by 3. I don't really care about the coefficients to find the patterns. Does that make sense to you? Okay. Because some people are like, whoa, 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 like, shouldn't I be getting the No, we're just trying to get the pattern here, okay? So the pattern would start with x to the power, the first term to the power 10. Remember when we did our expansion? Then the next term, so it's going to be something x3, whatever, right? Then it's going to be something x3, 9, and then the second term is going to be minus 2 over x squared, 1. Do you know how it's counting up, right? The second term's counting up, the first term's counting down. So what would I get here? I would get x to the power 30 for the first term. What would I get here? I'd get a 27, and then I have a 2 at the bottom. So I'd get x to the power 25 for the second term. So knowing that, what would my third term be? X to the power 20. You might want to do the third term just to make sure that you actually establish the pattern correctly. So just for fun, we'll do that. So this would be x to the power 3 to the power 8, and then negative 2 over x squared to the power 2. Does everybody see I get 24, and then I have a 4 at the bottom, so I do get 20. I did it right. So knowing that, that's my third term. So what would the x to the power 15 be? The fourth term. So now we're going to find T4. Do you see what I did there? Now I can actually find term 4. Okay, so again, here's the second method. This is usually the method of preference. I call it the algebra method. Okay. The reason why the algebra method works better is it works for solving for k and also solving for n. And the pattern doesn't necessarily work for n. Okay? So this works no matter what. But I guess I'm showing you that first method just for any reason you draw a blank, you know you can expand it and figure out a pattern to get the rest. It's all about patterns here, right? Okay, so the algebra method says that tk plus 1 is equal to nck, the first term to the power n minus k, the second term to the power k. That's just the formula, right? So what I'm doing here is I'm going to match what I know to what I need to know. So for instance, again, I don't need to know the coefficient, right? But I do know that the first term was x cubed, and that's to the power n minus k, so 10 minus k. Does everybody see that? And then the second term is negative 2 over x squared, and that's the power k. And again, I don't need to know about this negative 2 because it's not attributing to my x's. So if I simplify this, what do I get here? X to the power 30 minus 3k, and what do I get here? X to the power 2k at the bottom. Yes? What does that simplify to be? X to the power 30 minus 5k. Does everybody see that? Because when you're dividing, you subtract the exponents, right? Okay, so does everybody see that is supposed to match x to the power 15? So if the bases are the same, the exponents are equal, and then we just solve for k. So that means 30 minus 5k equals 15. Move the 30 over to the other side, we get minus 5k equals minus 15. So k is 3, which means I'm finding what term? Term 4. So term 4, that means k is 3, n is still 10, right? Yes? So this is equal to 10c3, the first term, which is x cubed to the power 10 minus 3, 7. Then it's the second term, which is negative 2 over x squared. And that's to the power 3. Does everybody see where I'm getting this from? Okay, so in the end, we better get some coefficient times x to the power 15. Does everybody understand? Otherwise, we did the first part wrong. Yes? So 10ck. This takes some practice, just so you know. Is 120. What do I get here? X to the power 21. What do I get here? Negative 8 over x to the power 6. Hey, look at that. We are going to get x to the power 15. So what's 120 times negative 8? Negative 960, x to the power 15. 120 times 8 is 960. See, now we have to find the constant term. Does anybody know what the constant term means? No, it's not necessarily the last term. The constant term means it doesn't have a variable. So this is something x to the power 0. So which method do you want to find that term number? You want to find the algebraic way because you want to review that? Because honestly, with the pattern way, we could actually keep on going and I'll find it in a second that it is. That's the 5th. That's the 6th. We know it's the 7th term. But I think we need to review the algebra way because I think algebra way is better. So again, the way this is working, remember this is x cubed minus 2 over x squared to the power 10, right? That's the question? Okay, so again, we don't care about the coefficient. The first term is to the power n minus k, so 10 minus k. The second term, which is negative 2 over x squared, that is to the power k. And again, we don't need to know about that part of it. So what does this simplify to be again? X to the power 30 minus 3k over x to the power 2k. That simplifies to be the same thing we got before, x to the power 30 minus 5k. Remember, we're looking for x to the power 0, which means 30 minus 5k equals 0. Move the 30 over, I get minus 5k equals minus 30. So k is 6, which means I'm finding term 7, which I already figured that out from before. So let's find term 7 and better hope there's not an x in it. Yes? So term 7 equals 10ck, 10c6. The first term, which is x cubed to the power 4, n minus k. The second term, which is minus 2 over x squared, and that's to the power k. So what's 10c6? X to the power 12. Is everybody good so far? What's negative 2 to the power 6? 64 over x to the power 12. Hey, look at that. X to the power 12s will cancel with x to the power 12. And what is my final answer? 13,440 with no x. So find the term that contains x to the power 3. So you guys want to do the algebra way again? Okay, so how do we do that again? NCK, so I don't care about that, right? The first term, which is x to the power n minus k, so 7 minus k. The second term, which is 1 over 2x, and that's to the power k. So I don't care about this number here, right? So what does that simplify to be? X to the power 7 minus k over x to the power k. Does everybody see how I got that? Okay, so what does that simplify to be? X to the power 7 minus 2k, and that's supposed to be x to the power 3. Does everybody see that? So now 7 minus 2k equals 3, minus 2k equals minus 4, so k equals 2. So we are finding which term? Term 3. So term 3 is equal to NCK, so 7C2, yes? The first term, which is x, and that's to the power n minus k, so that would be 5. The second term, which is 1 over 2x, is to the power k, which is 2. So 7c, well, we should be able to do this one probably without a calculator. Well, let's just do the calculator. 7c2 is 21. X to the power 5. And then if we have a 1/2 to the power 2, we get 1 over 4. And what's the x going to be? X squared. So what do we get as our final answer? 21 over 4, and what's the x to the power? X to the power 3. And that's exactly what it asked for, the term that contains x to the power 3. Okay, so the next question is the reason why I prefer the algebra method over finding the pattern. Sometimes you're not given the n. If you're not given the n, you can't do the pattern way because you don't know what to start with, right? So, the 7th term, so what are they giving you when they tell you it's the 7th term? K equals 6, very good. So the 7th term, yes, they're giving you T7, but it doesn't really attribute, it's more that they're giving you K is 6, right? Of this expansion contains the constant term x to the power 0, just in case you didn't realize that the constant term was x to the power 0. Find n. So let's do the algebra way. Do you want to try this? Okay, so NCK, we don't need to know, blah, blah, blah. So then it's the first term, which is 2x to the power n minus k. So what am I going to put there? N minus 6. Yes? I don't know what n is, right? The second term, which is minus 1 over 2x, that's going to be to the power 6k, right? Again, I don't care about the coefficients, blah, blah, blah. There you go. It's all gone. Even the negative, I don't care about. So what does that simplify to be? X to the power n minus 6, and then I have an x to the power 6 on the bottom. So what does that simplify to be? X to the power n minus 12. And that's supposed to be compared to x to the power 0. So what does n equal? N minus 12 equals 0, so n equals 12. And that's all we had to find. We didn't actually have to find the term, right? It just says find n. You know when they asked this question before in the provincial exam, some people just use guess and check until they finally got it. So 12 is high enough that it'll take you a little bit. And again, you hope that this is on the calculator part. Otherwise, you're going to be spinning your wheels here. Okay, the last example is, wow, this is a long lesson. The fourth term in the binomial expansion is qx squared minus 3 over x to the power 10. And they give you the term, but you need to find what q is. Okay. So the fourth term, they're giving you what? K equals 3. Very good. N is 10. So let's expand it. Term 4, which is 41,400, sorry, I said that wrong, 414,720 x to the power 11 is equal to NCK. So 10C3, the first term, which is QX squared to the power 10 minus 3, which is 7. The second term, which is negative 3 over x, and that's going to be to the power 3. Everybody good with what I did there? So 10C3 is what? 120. So 414,720 x to the power 11 is equal to 120. Q to the power 7, x to the power 14 times minus 27 over x to the power 3. Is everybody good with what I did there? Okay, so now I'm going to simplify 120 times minus 27. Oops. 120 times negative 27. So 414,720 x to the power 11 equals negative 3,240 x to the power 11. Is everybody good? Oh, I forgot my q. Sorry about that. Sorry about that. That's what we're solving for. Q to the power 7, x to the power 11. So if they're both x to the power 11, that means that 414,720 equals negative 3,240 q to the power 7. Is everybody good with what I concluded out of that? Okay, so I'm going to take 414,720 divide by negative 3240. And I get negative 128 equals q to the power 7. Does anybody know how to solve what q is? A 7th rooted. Did you know that you had a 7th root on your calculator? Yes, you can do it that way, or you can just do negative 128 to the power 1/7. That might be the fastest way. And probably you know the answer anyways. -2.